So we've done annuities, now let's do assurance. So for assurance, we have capital A. Okay, assurance is where money is paid on the death of the policyholder as opposed to on the survival of the policyholder. Okay, so you just get one payment, and that is in the most basic form at the end of the year of death. If you're wondering what the difference between assurance and insurance is, they both mean the same thing. Assurance historically tends to be used in the context of life insurance as opposed to car insurance or house insurance and something like that. But they're not different things. They are basically the same thing. Okay, so let's look at AX. That is the value of £1 payable at end of year of death of life aged X. Okay, so what's AX worth? Okay, and when we write AX, capital A for assurance, we do mean the present value. That is the notation for the present value. So I can just write it is equal to whatever it is equal to. Well, we might die in the first year. Okay, so I'm going to write that as QX times by V. Okay, because if we die in the first year, we get the payment at the end of the year, which means we've got a discount by 1 year. I've missed off the 1 here because that's a convention. If it's a 1, you can just miss it off. So QX means the probability a life X dies in the next 1 year. Okay, if it's 2 years, I have to put the 2 in there. Okay. Now, there's some basic rules about mutually exclusive outcomes. So you can't die in year 1 and die in year 2. Therefore, I can add the probabilities together. Okay, you can't normally add probabilities together because you'd have to take off the probability of A intersection B, so to speak. But there is no A intersection B when the two events are die in the first year and die in the second year, because you can't die in both years. If you die in the first year, you won't die in the second year. So we can add these probabilities together. And we can certainly add these present values together as well. So there is a bit of insight behind this, but largely be guided by common sense most of the time. So that's the value that comes from dying in the first year. Dying in the second year, okay, you have to survive the first year, PX, then you have to die in the second year, but the second year starts at age X plus 1. And if you do die in the second year, the value is V squared. Okay, the third year you've got to survive 2 years. You survive 2 years from aged X. Okay, you then die between age X plus 2 and the next year, and V cubed. Okay, 3px qx plus 3 v to the 4, etc. And as with annuities, we have these tabulated in our red tables. Okay, so in your red tables you will get a table there, AX as well. Might be a few columns apart. So we're given these numbers because, again, we can't just do all these calculations in the exam. It'd be too much trouble. So we're given them and tabulated, and we have exactly the same issue now of how do we deal with a term assurance. Okay, because just like with an annuity, we might only want it for a certain period of time. In fact, it's more common with assurance, because you might be wanting life assurance while your children are still dependent, whereas with an annuity you probably want it for the whole of your life. Although when we're doing the calculations of premiums and stuff like that, the premium calculation involves saying how much is the benefit worth, the assurance, and then how much are the premiums, and the premiums are an annuity, so the annuity will be temporary if the benefit is temporary. So that's a more advanced topic which we will come on to, but for the time being we want to look at how we actually calculate a temporary assurance, a term assurance. So a x n. Okay, so this is only going to go up to qx dot v plus px qx plus 1 v squared, and the last term is going to be p is going to be n minus 1 px q n minus 1 v to the n. Because if you die in the nth year, okay, you had to survive n minus 1 years, you've got to have the mortality of an n sorry, that is in fact, let me get rid of that. Okay, so the second, it's q x plus n minus 1. Okay, so what is the thing we're taking off? Okay, so just like with annuities, we're having to take off something. Okay, what is this thing, this sort of shadow thing we're taking off? Well, it's n p x q x plus n v to the n plus 1. Da, 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 da. Okay, so just as with annuities, I want to make the first term qxv. Okay, essentially, like this is the first term like that, then I can factor it out and I can have something that looks the same. I can have sort of axn equals ax plus some probability times v to the something times ax something else. Okay, so let's take this expression, let's take it down here, n px, I'm going to get rid of that, I'll do it in a different colour so we can see it. Okay, n px qx plus n v to the n plus 1 plus n plus 1 px qx plus n plus 1 v to the n plus 2, etc. That is going to be equal to, well, what do I have in each term? It actually turns out to be, and with fairly good reason, what I factor out is exactly the same as what I factored out before. Okay, because if I look at this, okay, so if I look at this expression here, having factored out this, I'm just left with q x plus n dot v. Okay, which is very similar to that, only it's x plus n rather than x. Okay, then plus I factor npx out of n plus 1 px, and I get p x plus n. Okay, I've not factored any of the q out. The mortality probability sort of stays the same, and I've factored out n of the v to the n plus 2. Okay, and the next term, p x plus n plus 1, sorry, it's not p x plus n plus 1, it is, it's 2p x plus n. Q x plus n plus 2 v cubed. Okay, which is equal to npx times v to the n times a, if you look at it, it's ax plus n. because I've got q x plus nv, like x plus n there. I've got p x plus n, q x plus n plus 1, q x plus n plus 1, p x there, q x plus n plus 1 there. Okay, 2 p x plus n, 2px, q x plus n plus 2, q x plus 2. So this whole thing is a x plus n. Okay, so that's the bit I have to take off to convert ax into axn. So let me do it in pink again. So assurance payable at the end of the year to life age X with a term of n years is equal to a whole of life assurance, which I can look up in my actuarial tables, minus npx, which I can look up in my actuarial tables as L x plus n over Lx, times v to the n, which I can just work out, times a to the x plus n, which I can look up in the actuarial tables. Okay. So again, it becomes, instead of having a two-dimensional table, I get a one-dimensional table. So that I look up. Similarly, that I look up. That I can calculate because it's just 1 over 1 plus I to the power of n, and this thing is just L x plus n over Lx, and I can look up L x plus n, and I can look up Lx. Okay, so that's how we do our assurance. That's how we can calculate any type of assurance. Same thing applies if it's age 50.2. Okay, just do age 50 and age 51 and interpolate.